According to the National Electrical Code, specifically Section 210.12b, all 120-volt, 15-ampere, and 20-ampere branch circuits that supply outlets installed in dwelling units are required to be protected by an arc fault circuit interrupter, or AFCI. There is a specific exception to this rule, which applies to outlets that are already part of a ground fault circuit interrupter, or GFCI, protected branch circuit. Let's break down what this means and why it's so important. Firstly, it's crucial to understand the purpose of an AFCI. These devices are designed to detect arcing faults in electrical wiring. An arcing fault is a dangerous condition where electricity jumps, or arcs, between conductors or from a conductor to a ground. These arcs generate intense heat, which can easily ignite nearby combustible materials, leading to electrical fires. Arcing faults can be caused by a variety of factors, including damaged or deteriorated wiring insulation, loose connections, or even nails or screws that have been driven into wires. Secondly, the National Electrical Code mandates AFCI protection in dwelling units to mitigate the risk of electrical fires. Dwelling units, such as apartments, houses, and condos, are considered high-risk areas because they often contain a large amount of combustible materials and are occupied by people who may be unaware of potential electrical hazards. The requirement for AFCI protection has been expanded over the years to include more areas of the home, reflecting the growing understanding of the effectiveness of these devices in preventing fires. Thirdly, let's delve into the specific requirements of NEC 210.12b. This section clearly states that all 120-volt, 15-ampere, and 20-ampere branch circuits supplying outlets in dwelling units must be AFCI protected. This means that any standard electrical outlet in a living room, bedroom, kitchen, or any other habitable area of a home must be protected by an AFCI breaker in the electrical panel. It's important to note that this requirement applies to all outlets, regardless of whether they are used for lighting, appliances, or other purposes. The key is that the circuit supplying the outlet is rated at 120 volts and either 15 amperes or 20 amperes. Fourthly, the exception to this rule is for outlets that are part of a GFCI protected branch circuit. GFCIs are designed to protect against ground faults, which occur when electricity leaks from a circuit to a grounded surface. Ground faults can be dangerous because they can cause electric shock. GFCIs work by monitoring the current flowing into and out of a circuit. If there is an imbalance, indicating that some current is leaking to ground, the GFCI will quickly trip the circuit, cutting off the flow of electricity. Because GFCIs already provide a high level of protection against electrical hazards, outlets that are GFCI protected are not required to also be AFCI protected. Common locations where GFCI protection is required include bathrooms, kitchens, and outdoor areas where there is a risk of contact with water. Fifthly, let's consider the application of these rules to the specific situation of studio apartments. In a studio apartment, there is typically one large room that serves as the living room, bedroom, and kitchen. Because there are no separate bedrooms, the entire living area is considered a dwelling unit, and all of the outlets in this area must be AFCI protected, with the exception of those that are part of a GFCI protected circuit. This includes outlets that supply the bed, kitchen appliances, lighting, and any other electrical devices. The outlets in the separate bathroom will also need to be considered. Outlets that are not GFCI protected need to be AFCI protected. Sixthly, it's important to understand the difference between AFCIs and GFCIs and to know when each type of protection is required. AFCIs protect against arcing faults, which can cause fires, while GFCIs protect against ground faults, which can cause electric shock. In general, AFCIs are required for all 120-volt, 15 ampere, and 20 ampere branch circuit supplying outlets in dwelling units, while GFCIs are required in specific locations where there is a risk of contact with water, such as bathrooms, kitchens, and outdoor areas. It is possible to have both AFCI and GFCI protection on the same circuit. In this case, a dual-function AFCI/GFCI breaker can be used in the electrical panel. Seventhly, when installing AFCI protection, it's essential to follow the manufacturer's instructions carefully. AFCIs are sensitive devices, and they can be prone to nuisance tripping if they are not installed correctly. It's also important to test AFCIs regularly to ensure that they are functioning properly. Most AFCIs have a test button that can be used to verify that the device is tripping correctly. If an AFCI trips frequently, it's important to investigate the cause of the tripping. It could be a sign of a genuine arcing fault in the wiring, or it could be a sign that the AFCI is faulty and needs to be replaced. Eighthly, it is also important to note that the National Electrical Code is updated every 3 years, and the requirements for AFCI protection may change over time. It's therefore important to stay up to date on the latest code requirements to ensure that your electrical installations are safe and compliant. Electricians and other electrical professionals should consult the latest edition of the National Electrical Code and any applicable local codes before beginning any electrical work. Ninthly, for studio apartments, consider that even though there is not a defined bedroom, the area where the bed is placed is still considered a sleeping area. Therefore, the AFCI requirements still apply to those circuits feeding that area. In a larger house with defined bedrooms, the code is very specific about the need for AFCI protection in those bedroom circuits. The same logic would apply to the studio apartment. Tenthly, it's crucial to remember that electrical work can be dangerous, and it should only be performed by qualified individuals who are familiar with the National Electrical Code and other applicable safety standards. If you are not comfortable working with electricity, it's best to hire a licensed electrician to perform the work for you. Attempting to perform electrical work without the proper training and experience can be hazardous and can lead to serious injury or even death. 11thly, understanding the scope and application of NEC 210.12b is crucial for ensuring electrical safety in dwelling units, including studio apartments. By adhering to these requirements, you can significantly reduce the risk of electrical fires and protect the occupants of these dwellings from potential harm. Always consult the latest edition of the NEC and local amendments for the most accurate and up-to-date information. The rationale behind the AFCI requirement is compelling when considering the potential sources of arcing faults in a residential setting. Consider older homes with aging wiring. Over time, the insulation on wires can become brittle and cracked, exposing the conductors beneath. This degradation can lead to arcing faults, especially in areas where the wiring is subject to movement or vibration. Even in newer homes, arcing faults can occur due to improper installation techniques, such as loose connections at outlets or splices. These loose connections can create resistance, which generates heat and can eventually lead to an arcing fault. Furthermore, the increasing use of electronic devices in homes has created new opportunities for arcing faults. Many electronic devices have power cords that can become damaged or frayed over time. If the insulation on a power cord is compromised, it can create an arcing fault, especially if the cord is pinched or bent. The risk is further amplified by the widespread use of power strips and extension cords, which can become overloaded and create additional points of failure. AFCIs are designed to detect these subtle arcing faults before they can escalate into a fire. They do this by monitoring the electrical waveform for patterns that are characteristic of arcing. When an AFCI detects an arcing fault, it quickly trips the circuit breaker, cutting off the flow of electricity and preventing a fire from starting. The effectiveness of AFCIs in preventing electrical fires has been demonstrated in numerous studies. These studies have shown that homes with AFCIs have a significantly lower risk of electrical fires than homes without AFCIs. In light of this evidence, the National Electrical Code has expanded the requirements for AFCI protection over the years to include more areas of the home. Another important aspect to consider is the different types of AFCIs that are available. There are two main types of AFCIs: branch/feeder AFCIs and outlet branch circuit AFCIs. Branch/feeder AFCIs are installed in the electrical panel and protect the entire branch circuit. Outlet branch circuit AFCIs are installed at the first outlet in the branch circuit and protect the wiring downstream from that outlet. Both types of AFCIs are effective in preventing electrical fires, but they offer different levels of protection. Branch/feeder AFCIs provide broader protection because they protect the entire branch circuit, including the wiring inside the walls. Outlet branch circuit AFCIs only protect the wiring downstream from the outlet where they are installed. Choice between branch/feeder AFCIs and outlet branch circuit AFCIs depends on the specific application and the level of protection that is desired. In some cases, it may be necessary to use both types of AFCIs to provide comprehensive protection. When selecting an AFCI, it's important to choose a device that is listed by a recognized testing laboratory, such as Underwriters Laboratories or all. This listing ensures that the AFCI has been tested and meets the applicable safety standards. It's also important to choose an AFCI that is compatible with the electrical system in the home. AFCIs are available in different voltage and amperage ratings, so it's important to select a device that matches the ratings of the branch circuit that it will be protecting. In addition to installing AFCIs, there are other steps that can be taken to prevent electrical fires. These steps include regularly inspecting electrical wiring for damage or deterioration, replacing damaged or frayed power cords, avoiding overloading power strips and extension cords, and ensuring that all electrical connections are tight and secure. It's also important to have a qualified electrician inspect the electrical system in the home periodically to identify any potential hazards. By taking these steps, you can significantly reduce the risk of electrical fires and protect your home and family from harm. Therefore, the requirements of NEC 210.12b should be strictly adhered to for the safety of the occupants.